In this video, we're going to talk about multiplicity and how it affects its behavior at each of the roots. So the first thing that we're going to do when we look at multiplicity is we're going to see what defines it. So let's say that I had a function f of x is equal to x plus 3 squared times x minus 7 to the fourth times x plus 2 cubed times 5x itself. So remember again that the degree is going to be the sum of all the degrees on a factored form. If it was multiplied out, it would be the largest degree, but when we're looking at this at a factored form, it's going to be the sum. So we got 2 plus 4 plus 3 plus 1. So this has a degree of 10. So we know this is positive, it's even, so we know the end behavior is going to go up that way for a little bit of review. But the multiplicity refers to the values at on each exponent. So this has a multiplicity. So at this root, remember the roots are from factored form, so the root is here at -3, but the multiplicity is 2. This has a root of 7, but the multiplicity is 4. This has a root of -2, but the multiplicity is 3. And this has a root of 0, but the multiplicity, it's not written, but it's understood to be 1. So let's look at an example and see how it affects it. Oops, let's get the right graph going on. So I'm looking at this graph here, and I have, again, two roots. We have a root here at 2, and we have a root here at 3, again, from this value, this equation here. But what I want to point out is when the root, this one at 2, when it has a multiplicity of 1, it crossed the x-axis, and when it had a multiplicity of 2, not the second one, it touched the x-axis, kind of what we call touching or bouncing. So let's look what happens if I change this to 3. Now we have both of them are crossing through at the roots. So let me change this back to 4. Now at that root, and if you notice, I'm only changing it on the binomial that has -3, so I know that it's going to bounce, because it's an even root, if you're starting to see the pattern. So if it was at 5, it would cross through. If it was at 6, it would bounce. So what I'm going to do over here is I'm going to change this to an even root. So it's kind of hard to see. I got to zoom in, but it actually is bouncing here. It's kind of coming down and going up. I've got these huge numbers. Let's see if I can change this to a lower multiplicity up here, but still be even. So again, we're bouncing at both roots. So the multiplicity is really affected. So let's look at this next one. If you look, I have a multiplicity of 3, so think about whether it's going to touch or cross. And then we have this one at 2, so think about that. So again, we still have the roots at -2 and +3. So let's see. So again, at -2, it had an odd multiplicity. And then at -3, it had an even multiplicity, so it's going to touch. So again, the odd multiplicity crosses at each root, even multiplicity touches. So sometimes we call it bouncing. So let's look. So at this root, it's even, so it's going to touch. At this root, it's even, so it's going to touch, and it's going to cross at these two odd multiplicities. So let's look at the graph itself. And so we have this here, and I'm going to zoom out a little bit so we can see all these places. Now, because we're multiplying by such large numbers, it's bouncing super high. It's got such a high y-intercept. But if you notice, it comes down and it doesn't cross through. So that's the touching at this root over here at -2. And then it's crossing, oh, excuse me, I'm sorry, at -3. I apologize. And then it's crossing here at -2. It's crossing here at 0, and then it's touching at 7. So this is how we determine it. So now what we're going to do is we're going to put it all together to try to sketch the graph. So pause the video and go ahead and get all these notes. So let's look at each of these, and we'll follow these rules straight through. So the first one says use the degree and the negative positive to determine the end behavior. So I notice that we have a sum of 5, so it's degree of 5. It's a negative function. So I know it's going to go up and to the right, excuse me, up and to the left and down and to the right. Then we're going to determine the roots. So we have a root at 4 and a root at -1. Some people think I have a root at 0, but there's no x value here. So I'm only going to have the roots here and the roots here. Now we're going to plot the end behavior. Now remember, it says that I said the last root goes up and to the left and this one goes down and to the right. And this is a sketch. We are going to get our y-intercepts off. We're not going to rise and fall as much as we should, but these are the properties right now that we're concerned with. So now what we're going to do, part 4, is we're going to use the multiplicity to determine whether we cross or touch. So again, remember, the exponent is even, so that means that this one is going to touch. And this one is odd, so it's going to cross. Now it's confusing because we always want to look at the root. I don't care about the root. So I always, because they're never in order on my graph, I look at -1, I'm telling myself I've got to cross here, and at 4 I've got to touch here. So I'm going to cross down, and it's going to touch and come down. And it will always line up. If all of a sudden you have to go this way, well, I said my end behavior is going to go down and to the right, so I know that somewhere something is wrong. And let me get, yep. So we're going to do that. Let me cross again and touch. All right, so let's look at the next one. Same process. We're going to look at all of my degrees. So this is going to be even because it's a total of 6. It's going to be positive, so I know my end behavior is going to go off in this way. So I wanted it to be purple. That's okay. So I know that my roots are going to be at 0, because this one did have an x with it, 2, and -5. So I'm going to plot it 0, 2, and -5. So we've got number 2 done. Number 3 says plot the end behavior. I said here it's going to go up, and here it's going to go up. So that's what we're going to do there. Now we're going to use the multiplicity to determine the end behavior. So here it's going to, it's 1, so it's going to cross. Here it's going to cross, and here it's going to touch. So I'm going to remind myself, over here it's touch, cross, and cross. So that's what we're going to do. I'm not going to cross through like that. Nope. I'm going to cross, touch, touch, cross, and then cross, and it will line up as it should.